My name is Alice from Infona. Welcome to NowWell, the first online platform that connects environment researchers and journalists.
My name is Gerald Tenywa. I'm a senior multimedia journalist working with a New Vision newspaper, and I've been working there reporting on the environment for the past 20 years.
My name is Mary Akurut. I have a doctorate in engineering science, focusing on water resources and climate change. My research interests are in water quality, climate change around Lake Victoria, and I'm currently working with the Uganda Electricity Generation Company as the manager dam safety and water resources.
The scientists believe that their role is to work in the lab, do their research somewhere in the research office, and they have no business with the media. And yet, the media can add value to their work by reporting it and making sure that it reaches so many people. And this has been quite a challenge. The Nile well is bringing these two parties together to be able to interact, to be able to chase the mistrust that has been existing between the two parties.
Nile well is a unique platform. It helps to interlink the journalists, the scientists, students and other researchers. It gives you a platform to also link to your own work, and also it gives you updates on the current and existing information that you have on the Nile basin.
You see, in many cases, the journalists, the first time, they may not get it right. But through continuous interaction with the scientists, they will be able to learn a lot more, and they will be able to learn correctly. I'm a living example of that. The way I was reporting 20 years ago is not the way I was reporting 10 years ago. And it is different from the way I was reporting 5 years ago.
It's important that we join this NowWell platform because it helps us to link between scientists and journalists and provides information to the public in a way that is really understood and information that is scientifically proven. So this is a good link that you need to join. So go NowWell.
So what are you waiting for? Create an account today by logging on to www.nowwell.org. Hi, my name is Alice from Infona. Welcome to NowWell, the first online platform that connects environment researchers and journalists.
My name is Gerald Tenywa. I'm a senior multimedia journalist working with a New Vision newspaper, and I've been working there reporting on the environment for the past 20 years.
My name is Mary Akurut. I have a doctorate in engineering science, focusing on water resources and climate change. My research interests are in water quality, climate change around Lake Victoria, and I'm currently working with the Uganda Electricity Generation Company as the manager dam safety and water resources.
The scientists believe that their role is to work in the lab, do their research somewhere in the research office, and they have no business with the media. And yet, the media can add value to their work by reporting it and making sure that it reaches so many people. And this has been quite a challenge. The Nile well is bringing these two parties together to be able to interact, to be able to chase the mistrust that has been existing between the two parties.
NowWell is a unique platform. It helps to interlink the journalists, the scientists, students and other researchers. It gives you a platform to also link to your own work, and also it it gives you updates on the current and existing information that you have on the Nile Basin.
You see, in many cases, the journalists, the first time, they may not get it right. But through continuous interaction with the scientists, they'll be able to learn a lot more, and they'll be able to learn correctly. I'm a living example of that. The way I was reporting 20 years ago is not the way I was reporting 10 years ago, and it is different from the way I was reporting 5 years ago.
It's important that we join this NIWEL platform because it helps us to link between scientists and journalists and provides information to the public in a way that is really understood and information that is scientifically proven. So this is a good link that you need to join. So go NIWEL.
So what are you waiting for? Create an account today by logging on to www.nawel.org.
Happy New
Hi,
Year.
my name is Alice from Infona. Welcome to...
Okay. Apologies for that. Good afternoon, everyone. Happy New Year. It's a belated one, but I hope you're all well. Thank you very much for joining us for the 9th edition of our NIWEL Science Wednesday, the 31st of January. I can see a couple of faces are making it for subsequent events. Thank you very much for making time to join us. Today, we are doing the 9th episode of the NIWEL Science Wednesday. I'll be your host, Deli Sive. I work as the communications officer at InfoNile. Maybe for those who are joining us for the first time, I'd like to let you know that InfoNile is a flagship project of Water Journalists Africa, which is a geojournalism group that covers critical stories on water and the environment in the Nile Basin. And we use data and science-based multimedia storytelling. So it is for this same reason that we hold NIWEL Science Wednesdays. And we hold these Science Wednesdays to facilitate learning and networking for both scientists and journalists based on the different science communication topics shared. And we have shared a couple of topics over the past 8-9 months. In December, we did one on Sudan. That was the GAD. We were checking on the effects of the GAD on Sudan, not South Sudan, on Sudan. And we hope all through these sessions, you learn something new and you develop story ideas. So before we embark on this session, I would kindly encourage us to introduce yourself in the chat box. You can write your name, your country, your organization, and your profession. In case you decide to tweet some of the things that will be discussed here, use our hashtag Sci Wednesdays. I'm going to share it on the chat box, and you can tag us at InfoNile. Okay, so other than that, I kindly request us to make this session as interactive as possible. Let us have minimal to unnecessary interruption. Kindly mute your microphone unless you're contributing. You can also type your questions in the chat box. You can also use the raise hand emoji. The session today, we are going to cover a topic by Dr. Albert Nkwasa from Uganda, but currently based in Belgium. The topic is on exploring water quality hotspots through SDG6 progress indicators. A brief overview of who Dr. Albert Nkwasa is. Dr. Albert is a research scientist from Vrije Universiteit in Brussels, focusing on the imprints of global change pressures on water quality from regional to global scales. The work he has done extends from climate impact attribution of changes in water quality. He has done an MSc in water resources engineering. He has also done a PhD fellowship at Vrije University. He completed last year, December, and he's currently investigating the drivers of pollution in African freshwater ecosystem. So currently, this has also led to what we're going to discuss today. Dr. Albert is mapping water quality hotspots in Africa, assessing the progress towards Sustainable Development Goal Target 6.3. Maybe just to note, the SDG6 aims to improve water quality worldwide. In 2022, Dr. Albert was awarded the prestigious Ernest Dubois Prize for his ongoing research on water pollution in Africa. This prize, the Ernest Prize, is awarded to the Corning, is awarded by Corning to support researchers in their research to water-related projects. So I can see Dr. Albert is already here with us. Dr. Albert, good afternoon. How are you?
Hi, how are you? Can you hear me?
Yes, I can hear you loud and clear.
Okay, good. Should I jump in here or?
Yeah, I was just saying hi. How are you?
Okay, hi.
Thank you very much for making time to join us. Maybe you could just say hi and embark on. Maybe you can give us a brief preview about your research, what it entails, and then you dive into it.
Yeah. Okay. Thank you for having me. Yeah. So I'm mostly you pretty much given me a very modest introduction. Thank you. Yeah, like you said, I work with the mostly large scale water quality modeling. So from continental to global modeling, looking at freshwater systems, but specifically focusing on water quality. Currently, I'm based in Brussels at the Vrije Universiteit Brussels, but next month I'll be moving to Vienna, Austria, joining an Institute of Applied Systems Analysis, EASA. And yeah, I'll talk about the SDG mapping that I've done, SDG6 mapping that I've done in Africa, which is currently under review. So hopefully it can get published soon, and you can also get access to the results easily. So I hope the presentation is informative as well as interactive. And yeah, let me know after the presentation, just shoot any questions that you have, and I'll share to the best of my knowledge what I know about water quality in Africa. So I think I can share my presentation now, right?
Yes, you can.
Okay. Yeah, so is it, can you see it well?
Yeah, yes, we can. I hope everyone else can see it as well. Yes, it's visible on our end.
Okay, sure, that's good. Okay, that's nice. Yeah. So yeah, I'll be mostly talking about hotspots of SDG progress indicators, and I will shed more light on what these indicators are and how they're measured and reported according to the Sustainable Development Goal 6. So to give you a bit of context, global pollution, about global water pollution. There is a recent UNEP report that states that about 3 billion people are at risk due to the scarce data on water quality. And this is because the quality of water resources is globally mostly unknown, as you'll see later on the subsequent slides. Yet reports show that unsafe water or polluted water kills more people than natural disasters and conflicts combined. At least from this report from the Uppsala Conflict Database, shows that over 500,000 people in 2020 died due to unsafe water globally, compared to about 90,000 people from natural disasters and conflicts combined. However, it's good to note that most of these deaths occur in the global south, so that is in Africa, parts of Southern America, as well as a few parts of Asia. But what do we mean by unsafe or polluted water? So water quality is made up of several constituents. So you have things like, algae, dissolved oxygen, water temperature, metals, salinity, several constituents. And water is considered polluted or unsafe if the thresholds of these constituents do not meet thresholds set by governing bodies. For example, World Health Organization or the United Nations Environmental Program. So if the threshold of these constituents are exceeded, then water is considered to be unsafe or polluted. Now, the main drivers of water pollution globally can be classified into mainly two sources. So you can have point sources of pollution. This is mostly from wastewater treatment plants or industries that discharge directly into a water body. So that could be a lake or a river. Or you could have non-point sources of pollution, such as atmospheric deposition. So you have deposition from the atmosphere, or you could have runoff from agricultural areas. So after applying fertilizer and manure, you have this runoff that ends up into a water body, or even natural areas where you have the soil erosion, moving the sediments or the soil particles from the land phase into the river phase. But then nowadays, we see that climate change adds, a new level of uncertainty. And in the recent IPCC report, it classifies this field of climate change on water quality as incipient. So by incipient, it means that this is, an upcoming field and not much is known about the impacts of climate change on water quality. However, according to the FAO report, it's good to note that agriculture and not human settlements or industry is the biggest source of water pollution. And this brings me to the focus of the specific pollutants that we look at, which are nutrients that come mainly from agriculture areas. Now, these nutrients are in form of fertilizer is applied onto an agricultural area. And when it rains, you have this rainfall event that leads to the movement of particles from the land phase into a water body. And the recent study by Bausen shows that phosphorus, form of fertilizer that is applied on agriculture areas, is the largest source of pollution in surface waters within the 20th century. And it's not only the largest source of pollution, but it's also increasing with time. Zooming into the African continent, when we look at the inland bodies, there have been cases where we've seen levels of nutrients, so levels of nitrogen and phosphorus, high levels of these being reported in water bodies across a few African inland water bodies. And not just the inland water bodies, but also coastal areas around the African continent. Recently, over 20 cases of coastal eutrophication have been reported. By eutrophication here, we mean that there is an increase in nutrient loading into a water body, so mostly from the inland systems into these coastal waters, leading to these hypoxic, so areas that have limited dissolved oxygen, which affects, of course, the water ecosystem, animals within the water body like fish. However, the World Bank report still classifies this that, the water quality is an invisible water crisis, because even though we have these isolated cases of eutrophication being reported in inland water bodies or even coastal areas, we really do not know much about the water quality issues globally, not just within the African continent. And it's also being highlighted within these sustainable development goals, because there is the SDG6 that is used to track this progress being made to achieving this good ambient water quality. And when we dig into this SDG 6.3, there is indicator 6.3.2 that tracks the percentage of water bodies with good ambient water quality. And I will explain later how they define this term, the good ambient water quality. But quickly, to give you a snapshot into the recent UN Water Report, 3 key points were highlighted. And one was that there were no reported values for most of the countries in the Global South for water quality. Secondly, these poorer countries always used less data to calculate these SDG indicators. And thirdly, these nutrients, which we've seen that predominantly come from agriculture areas, when measured within the water quality, within the water resources, they always failed to meet their targets more often than any other water quality constituent. Now, we do not have a lot of these reported values, because when we look at this global, so this GEMSTAT is a global database of water quality, we see that in the African continent, there is no data, basically. And this is the one key message that I would really want you people to pick up, is that the density of water quality measuring stations in Africa is 100 times lower than the density used elsewhere in the world. So we can see that we really do not know much about the quality of water resources on the continent, because we do not have any monitoring data. And, we also try to look at what other techniques or sources that could exist that have tried to address this gap of water quality. We see that we noticed that there were only 2 models that tried to set up at the global scale to address this water quality issue, but most of them had a very spatial resolution. So they would present results at about 55 to 55 kilometer resolutions, which is very, very close. So you can imagine just presenting results at a very close resolution. So what we try to do in this work that we've done is that we try to bridge this data gap and modeling gap by providing and building this continental water quality model for Africa, and then we later use it to to map this SDG 6.3.2 indicator to see if we are making progress towards achieving good ambient water quality. So to take you through a quick, because this is a highly technical a part of the research is that we had to set up this continental water quality model. And we mainly use this global data set. So there are existing global data sets for soil and land and climate and reservoirs and dams, topography. And we set up this continental model first for the hydrology. So looking at the river flows and the water quantity in our rivers and dams for Africa. And this work has been published. And then later, we added in these point sources of pollution and non-point sources that I mentioned earlier on. So, we added in sources from agricultural areas, we added in pollution from industries, pollution from the atmosphere, so atmospheric deposition, and also pollution from the natural areas. And we focused on the total nitrogen and the total phosphorus that we've seen that mostly come from the agricultural areas. And this work was sort of like evaluated with very minimal water quality data that exists on the African continent to sort of ensure that we have this physical representation of the conditions on ground. So basically, a model is basically a simplification of the physical representation of what is happening on the ground. So now, after we set up this model, we used it to map this SDG so we can see the progress that we have done towards achieving this SDG indicator 6.3.2. And so to give you a bit of a background, the ambition of SDG target 6.3 is really improving the global water quality by 2030. So that is in about 6 years. We only have 6 years left to see how the progress we've done to achieving this target. And under this target, you have the SDG indicator 6.3.2, which monitors progress towards this target by assessing the water bodies. So there's lakes, rivers, and groundwater against good ambient water quality standards. Now, so what normally happens is that within the water body, you can have thresholds of good water quality based on using the human health as a target level, or you could use ecosystem target level, health target level. Now, by the ecosystem health target level means that you incorporate in other ecosystem habitants within these thresholds. So for example, you can have like fish, you can have also the other ecosystems within the water body that you incorporate into this target threshold. And this is what the SDG indicator focuses on. So it uses the ecosystem health target threshold. And there are several, like I already mentioned, there are several water quality parameters that could be used, but level 1 reporting, which we focus on the nutrients, so we focus on nitrogen and phosphorus in this study. But ideally, what we're doing right now, beyond this presentation, is that we are expanding it to also consider salination, as oxygen, as well as the pH, the acidification. Now, good ambient water quality is defined according to the United Nations Environment Programme if 80% or more of the monitored values meet their targets. So for example, let's say you have 5 years of monitoring data from a river in Kenya. So if you calculate and you find that 80% of the values monitored within those 5 years meet the threshold that is set for water quality, then it can be considered as good ambient water quality. If less than 80%, then it's not considered as good ambient water quality. Now, in this study, because we are looking at the African continent, whereby several countries have different thresholds, we use the optional benchmark targets set by the United Nations Environmental Programme for the nitrogen. So we use these targets of 0.7 and 0.02 milligrams per liter for nitrogen and phosphorus. But what we do here is that we replace the monitored with simulated values, because we do not have monitored values in Africa. So we use the simulated values from our model to be able to calculate this indicator. And we determine the proportion of daily simulated values. So we use 10 years from 2020 to 2019 that fall below these target thresholds for both nitrogen and phosphorus across the African continent. So our results here, as you can see, we find that for phosphorus constituents, 45% of the rivers do not meet this good ambient water quality threshold. For nitrogen, 14% do not meet this good ambient water quality threshold, while 33%, when we combine these constituents, we find that the 33% of our rivers do not meet these thresholds. And this work is now under review. We've submitted it for publication. But when we try to highlight, to try and define the drivers or the sources of this, we look at fertilizer and manure application across the continent. We look at point source discharge. So point source is wastewater discharges into the river system across the continent. And also we factor in rainfall, so precipitation also across the continent. And we see that areas where we see the red lines, meaning that these are areas that have the least, so do not really achieve these thresholds. So the only 20% of the values achieve the threshold, and meaning that they're most polluted. We see that most of these areas coincide with areas of high fertilizer and manure application, as well as wastewater discharge. But most interestingly, also some of these areas, like in the Nile Basin, as you see here, they also coincide with areas where you have less precipitation. Now, with less precipitation, or which is same as rainfall, the implications are that if you have less rainfall, you have less dilution within your river system, meaning that if you have pollutants that are being loaded into a river system, then you have less water to dilute the pollutants, then you have higher concentrations of these pollutants. So that is where the precipitation, the rainfall or precipitation comes and plays a part in terms of nutrient distribution. So as you can see here, we see that the hotspots are mainly located in the Niger Delta, with parts of in the Congo here, we have in South Africa, as well as North Africa and parts of the Nile Basin. So some of the takeaways from this mapping are that 1/3 of African rivers fail to meet the good ambient nutrient standards. And we noticed that most of these rivers coincide with areas of high fertilizer and manure inputs, but as well as wastewater or point source loadings. And we recommend, of course, implemented targeted strategies for efficient application of these manure and fertilizer, as well as wastewater treatment is very crucial in Africa, especially in urban areas for the wastewater treatment. But then it's also, worth noting that majority of these rivers are still in good condition, because 67% of these rivers are still in good condition, which provides, opportunities for shortcutting further nutrient pollution. And it's good to note, maybe to also highlight that in this work, we focused on nutrients, but like I said, water quality is made up of also several other constituents, such as oxygen, BOD, you have temperature, metals, and salinity. So in this study, we focus mainly on nutrients, whereby the main source comes from agriculture and sometimes also from the wastewater discharges. And this is all that I have to share. I hope I've kept it brief and interactive and informative. And I would like to hear some of your questions. Yeah, thank you.
Thank you very much. I hope you can all hear me.
Should I stop sharing my screen or?
Yeah, it's okay.
I don't know if, maybe we want to have, I don't know how you do it. Maybe we want to have a discussion and chat face to face, or I don't know.
I think it is fine, because then you will be able to go back to the slides that maybe one would love to have maybe some bit of insight. Thank you so much.
Okay.
Okay, thank you so much for the presentation, Dr. Albert. And I like the fact that you've really simplified it from a scientific perspective to a perspective we as journalists can be able to digest and understand. As I'd like to ask everyone else on the call, anyone who has a question, feel free to type in your questions. In the meantime, Dr. Albert, I'd like to ask, you have, what could you say could be attributed to the difference in water quality between the Blue Nile, the main Nile basins, and the Lake Victoria? Because you had mentioned that there's a difference between the water quality and the main Nile and the Lake Victoria basin. what do you think would be the differences in this?
Yes,
Could make the difference.
Yes, so that's a very good question, because when you look at it from a basin level, you have several, water quality is made up of several interacting drivers. So like I mentioned, the main sources of pollution could be classified into point sources and non-point sources. So you have these interacting drivers of wastewater discharges, you have non-point sources. So you have, like, after a rainfall event, you have a wash off into the, from the land surface of soil erosion, from the land surface into a river system. Then also you have areas that receive less precipitation, so less rainfall, meaning that you have less mixing in the rivers to dilute these constituents. So I would say several drivers cause the different levels of pollution, especially across the Nile Basin. But I would say, for example, like in the Lake Victoria Basin, we know that Lake Victoria, there's a lot of atmospheric deposition, specifically for the Lake Victoria region. So then you have a very high chances that pollution from Lake Victoria can be caused, mainly driven by atmospheric deposition, so nitrogen and phosphorus from the atmosphere. But then it doesn't negate the fact that the shores of the lake also have influences from wastewater discharges, as well as runoff from urban areas. Yeah.
Okay. Thank you for that. I'll just ask my second question, and then I can see there are several other questions too on the chat box, and two others have raised their hands.
Yeah.
So keep your hands raised up so I don't miss you. Maybe my other question would be, in your research, you recommended implementing targeted strategies for efficient fertilizer application and wastewater treatment in Africa to address the issues in high nutrient concentrations in the water.
Yeah.
How do you think journalists can be able to contribute to this effectively?
Okay.
Or rather, have you seen any gaps in the way we are reporting as journalists that you'd like us to pull our socks on?
That's a very good question. I will answer it in two ways. One is that if technically, if you look at it from targeted efficient fertilizer application and wastewater, for example, like the different ways with which fertilizer and manure can be applied on an agriculture area. You could use broadcast application, meaning that you just spread the manure all over an agriculture area, or you could have even injection of this fertilizer into a soil layer. So of course, like injection into a soil layer reduces this runoff from the topsoil. So these would be different ways within which fertilizer and manure could be applied. And then for the industrial wastewater, there's a work that shows that about 80% of urban effluent is discharged directly into rivers and lakes from the urban areas. So we need to construct these wastewater treatment plants within urban areas. And I would say the journalists mostly would, if the journalists would come in an overarching goal of first highlighting that we do not know, we do not know most of the water quality within Africa. And this is mainly because of the huge data gaps that we have across the continent, or not just across the continent, but also within the Nile Basin. So if that can already be brought up in terms of highlighting that gap, then it will probably also trigger more policymakers or governments to be able to try and address this. And because if we do not know the quality of the water resources that we have, then how can we be sure that the water that we have is, fit for human consumption or ecosystem functioning?
Okay.
Yeah.
Okay. Thank you so much for that. Maybe I'd ask Douglas to come in first. You had raised your hand, and then Alem, you can come in second.
Yeah, thanks, Albert.
Douglas?
Interesting presentation. You can hear me?
Yes, Douglas.
Yes.
Yeah, I see you're focused on NNP, that is nitrogen and phosphorus. What about sediments? From where we sit, we are always trying to solve the sediment load issue within many river systems. And I think that would be very interesting, because most times attention is usually focused on improvement of that. And then the second question is for the NNP that you mentioned, what resolution do you have the results? Are they down to some small river systems or small subcatchments? Because that would be interesting, especially when it comes to working towards solving these problems at more like subcatchment scale. Because where in our organization, we try to go really down to the subcatchment level to try and solve this problem. So it's important to get that information. Thanks.
Yeah, thanks, Douglas. Yeah, I'll start with the sediments. Yeah, we also have the data for the total sediments and also erosion, because ideally, like we say, most of the nutrients, especially phosphorus, is transported with the sediments from the land phase. So these are soil particles whereby this phosphorus is attached to and it's transported into the river system. So you cannot really represent this phosphorus right if you cannot represent the soil erosion right within your model. So we have the data for the sediments, and we can provide it if it is needed. So this work is under publication, but if it's accepted, all these data sets will be freely available to anybody to use. And then in terms of the resolution, so this model also goes up to 1 kilometer resolution. So we could have, if we could have it at the sub-basin level. So if you're interested in the sub-basin in, for example, Kenya, say the Mara Basin, we could extract, you just have to extract that Mara sub-basin, and we give it to you, or you use it for your analysis or your management scenarios. So it goes up to 1 kilometer resolution.
Okay. I hope you answered. So Alam, you can come in second.
All right, thank you. Alam Gabriel from Houston. Thank you for the presentation. I missed a few slides at the beginning, but I got the gist of your presentation, and thank you very much for that one. I think I put a question on the chat about sediment also. I think sediment is the main culprit of water quality, especially the Blue Nile region. I'm from Ethiopia originally. I know that region very well. So you haven't mentioned it. I was kind of surprised, but you asked a question on sediment issue. But also it contributes for nitrogen, phosphorus, because it binds in that one. My question to you is, have you segregated, this water quality parameters into their sources, whether it's manure, agricultural application, or some other sources? The other question I have is, the model you said is 1 kilometer square. Is there any final resolution on that one? Because that's too coarse for especially water quality analysis. If that's what you have, then I guess it gives a very high level of understanding of the watershed, but that's very coarse resolution. Can you comment on that one? Thank you very much.
Yeah, thanks, Alam. Yeah, for the sediments, I think I have posted something in the chat. I hope you can see it. So it's what we did specifically also in the Nile Basin, looking at soil erosion and sediment yield, and when we also projected it in the future to see how the sediment yield will be. And like you said, yeah, the high levels of erosion within the Ethiopian highlands, mainly attributed to the precipitation and topography. But we have the sediment results as well in this continental model, if you are interested in that. The sources of pollution, yes, we identify different sources of pollution, and like we say, spatially there are different contributors to these pollutants. So in areas we did an attribution study, so looking at climate, land use, fertilizer, and manure, and then we were able to identify the different attribution sources, how we can attribute the main sources of pollutants across the continent, historically, for the historical period from 1951 until present. So spatially, there are different sources. I would say climate comes out because it's very easy for climate to influence water quality. Any slight change in precipitation subsequently influences water quality. So you find that climate is highlighted as a dominant driver. But then, of course, we have areas like in North Africa where we have mainly wastewater discharges. So effluents contributing a lot to erosion. And then you have in Southern Africa as well as West Africa where you have agriculture contributing to soil erosion. And then you have like in the Nile Basin, specifically at hotspots in Egypt, where you have agriculture and as well as wastewater discharges contributing to poor water quality. Now, in terms of resolution, that's a very good question because as you go on large scale, you have to strike this balance of giving a continental or a large scale model that sort of also still has meaningful interpretation at a local scale. But then it becomes very tricky because you cannot give very fine resolution at a very large scale because of you're striking a balance between data computation as well as model interpretation. So I would say that, of course, as you go more on large scale, you become more interested in terms of identifying sources of pollution, trends in pollution, as opposed to very finite absolute values. So I would say that, yeah, you could, if you're interested in a very, very localized scale, maybe you have a catchment that is a few kilometers squared, then it would be much better to set up a local model to be able to identify sources of that, as opposed to using a model from a sub-basin from a continental model. So it depends on your interests as well as on what you're trying to report. That's where the scale of application comes really much into play.
Mm-hmm. Okay.
Yeah.
Thank you very much for that, Dr. Albert. I think that was quite. You've really explained it intensely. I hope, Alem, you're well answered. Okay. David Jackie's hand has been up. I can see he's also typed on the chat box. Maybe David.
Yeah. Thank you for the good presentation. And my question is, could you comment on now maybe chemical supported agriculture and deforestation in the Nile Basin is threatening endangered wildlife that many depend on wetlands within the basin?
Yeah. Yeah, that's a very, very, very interesting, because wetlands are, yeah, we know that wetlands cover in Africa about 4% of the continental landmass, and they are reducing in percentage-wise because of encroachment for human activities. Now, that affects water quality in a very tricky way, because wetlands should ideally act as a buffer. So meaning that if you have runoff from the land surface, erosion, so sediments, or with these nutrients, they should get trapped into a wetland before they can enter into a water body. But of course, with the missing component of wetlands, what is happening now is that we do not have this buffer. So most of the surface runoff or the eroded water just enters straight into the water bodies. And this is, of course, intensifying and leading to more deterioration of the water quality. So we would need, I have seen activities, at least on the Ugandan side, in terms of Western restoration, to be able to address this through catchment management plans. But I'm not sure how basin scale this has been adopted across the Nile Basin.
Okay, and
yes, David.
And deforestation also, could you comment on how maybe it's threatening this wildlife that depends on wetlands in the basin?
Yeah. It's deforestation is it also works in two ways. So first of all, deforestation would ideally reduce the runoff speed. So meaning that if you have water on the surface and there are trees, then the speed is reduced. And then in a way, you have a subsequent reduction in terms of how these nutrients or sediments arrive into a water body. So when you remove these trees, then you have bare land and this soil erosion activities, and then subsequently leading to the deterioration of water quality within most of the rivers in the Nile Basin, at least around the Lake Victoria Basin. And also, secondly, in terms of atmospheric deposition, then if you have this forest, then you have the deposition that is happening on the vegetative cover. But without this forest, then you have the atmospheric deposition that goes directly onto the bare soil, and then later subsequently into the water body. Yeah. So of course, with what is happening is that there is an increase in deforestation, mainly due to population growth, and with expanding population growth, then there's this encroachment that happens on the trees, and then there's the subsequent resulting into bare land, and then later into an increase of runoff from the land surface into the water body. And this becomes tricky to address, because how do you tackle population growth? So it's very tricky to directly target and address.
Okay. I hope, Jackie, you well answered. Maybe there's a question on the chat box. Benjamin Kramer says, you mentioned that rainfall can have a dilution effect on pollution, but did you see the opposite, where higher rainfall increases nutrient runoff to water bodies?
Yes. That's a very interesting point. Yes, we could see that historically. I wish I had presented this map that we did, the attribution map as well. We saw that historically, most of the Africa is experiencing a drying trend. So meaning that in West Africa, we're having a drying trend. Southern Africa, we have a drying trend. But in Eastern Africa, around the Ruvu Basin, Ruvuma Basin, we have, for example, a wetting trend. So in those areas where we have a wetting trend historically, we could see an increase as well in terms of soil erosion, so sediment load, then subsequent increase in nitrogen and phosphorus. Meaning that, of course, with increase in precipitation, then you have increase in surface runoff, and then a subsequent increase into the water body. But it's good to highlight that the increase of precipitation can only result into an increase in of nutrients into a water body if there has been an increase on the application of nutrients on the land surface. So if there has been less application of nutrients on the land surface, so through agriculture or fertilizer or manure, then there will also be subsequent less movement of nutrients to a water body.
Okay. Benjamin also asks, you relied on a specific cutoff between good and bad water quality, but these cutoffs are a bit arbitrary. Do you consider adding more classes or just focusing on the continuous gradient instead?
Yeah, this is something we've had chats with UNEP, with Stuart Warner, who developed this indicator, because it's just a binary indicator. So meaning that it's either classified as good or bad, and it becomes tricky because how do you then set this binary indicator? And that is why you see in the presentation we could use we also put this part of ranges where, so we also added ranges from 0 to 20%, 20 to 40, and then we spread it until 80. So we also see regions where we achieve 60 to 80%. So yeah, that is in a way where we show that in some rivers, we don't have necessarily bad water quality, but it's not as good as we would have expected in terms of achieving this 80% threshold. So these are some of how we disintegrate the indicators. But ideally, the main concept of this indicator is just binary distinction of good and bad.
Okay, could it also be the reason why you're using good and bad is in being in liaison with what the UNEP's criteria for designated water body to be either good or bad?
Yeah. So 100%, everything we're trying to use here is designated. We're following just the UNEP. All we did was what we did here was just follow the UNEP designated definitions. The only difference that we had was that we used simulated values because we do not have observed values in Africa, but all the calculations and the thresholds were according to the UNEP designation.
Okay. So in the interest of time, I'm going to read the last two questions, then you can move to our quiz section. So the first question, sorry, I just missed it. This is a question by Alem has already asked this question. Chemical deforestation. Okay, so Bernard Bankukira says, in 2020, I was diagnosed with bilharzia. Then a doctor asked me if I used to live in Uganda. When I asked him why, he told me the whole Nile River is highly infected with this type of worm. I was so much interested. I'd like to know if this is true and the reason behind this. Maybe just to add on the last question. Okay, maybe I think Benjamin Kremers, I've read his question already. Okay. The last question is by Henry Owino. It seems it's clearly impossible to realize safe and clean water for all within 6 years, the SDGs 6 for 2030, as agricultural chemicals continuously pollute water among other industrial raw effluents discharged into rivers and lakes. But can it be achieved in our lifetime with this pollution rate? In short, it's just asking if this SDG 6, noting that SDG 6 seems to be impossible to be achieved by 2030, can it be achieved within our lifetime with the current rate of the pollution? Yeah.
Yeah. So I would thank you. I'll start with the bilharzia question, and yeah, it's true. There is the main, also a very high dominant pollution source in Africa is organic pollution. So it's where bilharzia sort of like comes from poor sanitation. So that is a very true point, that we have high levels of organic pollution in Africa and South America. And I will go to achieving this indicator. By 2030, personally, I think it's practically impossible. So I think the SDG will probably, indicators will probably be pushed to maybe like 2050 or 2100. But achieving it's highly dependent on socioeconomic scenarios that we take, not only as Africa, but globally. So that will include on how we handle birth rates, how we handle industrialization, agricultural growth, or population growth. So in a lifetime, it could be possible, but depending on the socioeconomic scenarios that we take, that we adopt globally.
Okay.
Yeah.
Thank you so much, Dr. Albert, for that. We are just about to get into the trivia section as we close the session today. Before we delve into this, I'd just like to let you know, everyone attending this, that we normally hold the trivia section to be able to gauge whether people were able to understand what was being presented, and also we award the top winners based on cumulative points. So for the first 6 sessions that we had, we awarded all the winners, but we have 2 winners who we don't have their details. That is Kicking Off from South Sudan, and we also have Razia Katelin Mawanga from Tanzania. Kindly send your emails to info@infonile.org so we can be able to send you your gifts. They've been staying in the office for over 4 months now. Kindly write to us, info@infonile.org, with details of how we can be able to deliver this to you. The other bit I'd like to mention is that in our Nilewell Science Wednesdays, moving forward, we are not awarding physical presence. Rather, we are giving a story grant, or rather attend an Infonile physical event wherever we shall be. We're also awarding a training and mentorship program. And for the last person, not really the last, number 3, based on the cumulative points after 6 months, we're going to give you Infonile merchandise, which would be a hoodie, a t-shirt, and a thermoclass. Yeah, so before we delve into that, for those who would want to know, maybe just a reminder, we are going to have this session. This session has been live on YouTube, and it's also live on the Nilewell platform. I've just posted the links. You can check them there. I'm also going to post the resource on Nilewell in case you'd like to get back to it. You can also go to Nilewell to reach out to Dr. Nkwasa if you'd like to reach out to him personally. So, Chris, the stage is yours. You can go for today's quiz section.
Thank you, Delegate. Thank you, Dr. Albert, for this wonderful presentation. It's been very interesting. My name is Christopher from Infonile as well. I'm here to just take you through a simple, light moment of trivia questions. Delegate, you help us keep score of whoever is answers the question first, and we can get it going and award these participants their prizes earlier. So, Deli, are we on? All right, everyone, let's go. Now, there are 5 trivia questions. Answer them to the best of your knowledge and according to what you have picked from our lesson today or thesis. All right, let's go. Question 1. Water pollution is a global challenge threatening 3 major functions, which are, so if you can list those for us, we have 3. Water pollution is a global challenge threatening 3 major functions. Yes, these trivias have been got from Dr. Albert's wonderful lesson and research today. Let me repeat one more time. Water pollution is a global challenge threatening 3 major functions. Those three major functions are
a quick one. The competition today seems quite tough. Any three functions, any three main functions that you know are challenged by water pollution? Okay, I think we shall pass that one. Maybe Chris, you can let us know what the answers are, then we move to the second question.
The three functions are human health, food limitation production, and reduction in ecosystem functions.
Yeah. That was one of the first things Dr. Albert mentioned at the beginning of the presentation.
Yes,
so,
yes.
Yeah.
Number two. Which statement is correct? Which statement is correct? Africa holds roughly, is it A, 99% of the planet's fresh water and is home to 16% of the world's population? Or is it B, 12% of the planet's fresh water and is home to 18% of the world's population? Or is it C, 7% of the world's fresh water and is home to 14% of the world's population? I'll repeat one more time. Which statement is correct? Africa holds roughly A, 9% of the planet's fresh water and is home to 16% of the world's population. Or is it B, 12% of the planet's fresh water and is home to 18% of the world's population? Or is it C, 7% of the planet's fresh water and is home to 14% of the world's population?
Okay. A quick one. So the answer is either A, B, C, or D. You can select one out of what he said.
C, A, B, C.
Yeah, A, B, C. I can see there's an answer already.
Prim is there with us. I think Prim is the first. No? Yes, Prim is the correct one. Prim is correct.
So there's Leonard. Okay, so tell us the correct answer.
The correct answer is A.
Okay, third question, please.
All right, that's wonderful. Question 3. Name 3 actions that characterize soil erosion. Name 3 actions that characterize soil erosion. One more time. Name 3 actions that characterize soil erosion. Name 3 actions that characterize soil erosion. Name 3 actions that characterize soil erosion. I think today's questions were tough.
Okay. You can maybe mention them and then we move to the next one.
All right. Soil loosening, transport, and deposition. Soil loosening, transport, and deposition. Those are the 3. Let's go to number 4, right? Let's go to number 4. The rainfall in the Victoria Basin, located within the equatorial region, exhibits a pattern which is the main. The rainfall in the Victoria Basin, located within the equatorial region, exhibits a pattern. What is the period of the main wet season in? So we want to say, let's say, is it from Feb to June? Is it from August to September? Is it from June to July? Just give us a small time frame. The rainfall in the Victoria Basin, located within the equatorial region, exhibits a pattern, right? What is the period of the main wet season? So you can say the period is from Feb to August, or from March to May.
Okay, maybe 2 seconds to finish up on this. Anyone with a rough idea of the main wet season in the Lake Victoria Basin? Any answers?
March to May, there we are. March to May, Annette has given us. Thank you.
Who is
Thank
the
you.
first answer? Henry.
Oh, Henry, eh? Henry is the first. Wow, wow. Thank you, Henry.
Yeah. Henry is the first
They
answer.
could share Bambi that point. I like how they
So
both can.
March, Henry and Annette.
Yes.
Henry and Annette have gotten it right.
Okay. All right. All right. Number 5. So as we've all listened to Doctor, what was the one thing he kept saying and saying and saying again that is translated into SWOT? So I will say, what does SWOT stand for? So if you listen to this, you all know it. What does SWOT, S-W-A-T, stand for?
Leonard. Soil water assessment tool. Wow.
Fantastic.
Leonard
All
has
right.
it correct.
All right, I think that's it. Delicate, are we clear? Are we all right?
Yes, we are. So the winners for today, we have question 2, Primrose. And then question 3, we didn't have anyone. Question 1, we didn't have anyone as well. And then question 4, Henry Owino. Question 5, Leonard Mukoli. So everyone today has gotten an average of 5 points. 5, 5, 5. We don't have a winner for today's session. So the points will be accumulating over the next 6 sessions. The winner will stand to get either an InfoNile story grant, attend a physical event, training or mentorship program, or InfoNile merchandise for the third in the accumulated points. Thank you very much, guys, for
Thank you all for
this
taking
session.
part. It was fun to have you all. Thank you.
Yeah. Okay. We have come to the end of the session. I would want to specifically thank Dr. Albert, who has joined us all the way from Brussels. And I would like to also thank a good number of the members of the team who have joined us. This is not the first time. I can see Henry Owino, I can see Annette, there was Jonas Kiriko from Rwanda, there was Suzanne Marmar, always the first to join our sessions. Thank you very much. Denise from DRC as well. We really appreciate your attendance and participation in the session. So to wind up, just a reminder, I have posted on the chat box where this session has been ongoing, both on Nylon and on YouTube. Kindly use either of the links shared to access contents of this session. We have come to the end of our session today. I want to say thank you once again for joining us. I'm going to send an email to every one of us with the recordings as well. If you are not able to attend the session, you can let your colleagues know about this. I will also send the details of the upcoming sessions in the subsequent emails. Dr. Albert, maybe I don't know if you have anything else to say. Other than that,
no,
we really
thank you. No, thank you so much for having me and
yeah,
giving me the platform to share what I do.
Okay.
And so thank you so much.
Okay.
Appreciate it.
Okay, thank you very much. Maybe as we leave, make a point, if you know of any researcher or scientist within the Nile Basin who has any recent and interesting research you'd like to share with us, feel free to write to us, info@infonile.org. Thank you once again. See you next time. Bye.
Bye.
Mm-hmm.